And this one actually says, using Hess's law, calculate delta H reaction for the reaction given here, given the following reactions and delta H reaction values. It says this reaction here has delta H reaction equals minus 3505.8. We have another and a third reaction, and it didn't quite format as well. It looked a little prettier on the page. And that says, please show all of your work, including, yeah, well, this is the same as before. It's even missing the closed parenthesis. And what I'd like to do now is, okay, so this is the reaction we're trying to make, and the arrow goes there. And I can see that in the reactions that I've got down here, I've got C5H12 as a reactant. And in the reaction I'm trying to make, I've got C5H12 as a product. And they both have 1 coefficients. So what I'm going to do for this reaction is I'm going to flip the reaction. And this delta H equals minus 3505.8. I'm going to do the minus of it. And so I'm going to write that down here. And when I flip the reaction, these two, C5H12 and 8 oxygens, are going to be products. And my 5 carbon dioxides and my 6 H2O gases are going to be reactants. So that's what I mean by flip the reaction. And when I flip a reaction for reactants and products, I'm going to take a minus sign to the delta H. And you can see that I've got 2 minus signs here. So 2 minus signs equals a plus. So I am going to write for this reaction, delta H reaction equals plus, so I'm not going to write the plus though, just 3505.8. And that's going to be kilojoules per mole. I think I can zoom in a little bit there. All right. And now what I've got is I've got 5 H2Os, sorry, 5 CO2s, and I've got 1 CO2 right here. And I can see that this is a product. Oh, and so here's what I'm going to do next. And this is a variation on the last problem. So in the reaction that I'm trying to create, there are no carbon dioxides. I have 5 carbon dioxides right here. So I am going to multiply this reaction times 5, which will give me 5 carbon dioxides on the product side. And that will cancel out my 5 carbon dioxides down here. So when I multiply times 5, that's going to give me 5 carbons, 5 oxygens, and 5 CO2s. And I'm going to multiply this times 5 as well. And so line up my arrow. I have 5 CO2s. I have 5 carbons, solids, and I have 5 O2s.
I have a question, Professor.
Go ahead, Jumbo.
I'm sorry. Did you multiply the 5 because of the CO2 or because of the carbon? Like, say for instance, you have a different, for the main reaction, what if there was a different value for carbon?
Oh, good question. So, and I missed that. So I am going to get my 5 carbons here as well. I don't know why I focused on the canceling the carbon dioxides, but I think actually your thought of making the 5 here is a better thought. And so what I will say is, so in our class, the reactions that you are given are always set up to perfectly make this reaction if you do the right changes to them. So you can see that I am creating 5 carbon solids, and I am also canceling 5 carbon dioxides. That will always work.
Okay.
Yeah, so these, think of these as, I mean, if we were out doing science, we would have to find these reactions in books, but here we will always be given the correct reactions. Okay, so now I have 5 times this number is going to be the delta H reaction here. And I don't know what that number is. So 5 times 393.5, and I'll put my minus in that time. Minus 1967.5. And that's kilojoules per mole. Yeah, no, so that's a good point. So we're making the 5 carbon solids, and we're canceling the 5 carbon dioxides, all just by adding this reaction. Now let's see. So now I'm going to do this one, and what you can see is I have 2 H2s, and I need 6 H2s. So I'm going to multiply this reaction times 3. And I'm going to multiply my delta H times 3 as well. And when I write that out, it'll give me my 6 hydrogens, and it will also give me 6 H2Os on the product side, which will cancel my 6, my video's frozen, but it will cancel my 6 H2Os on the reactant side. So 3 times 2 is 6.
6.
Yeah, go ahead. Thank you.
Plot 6O2 and 3O2.
Thank you.
Then the reactant side is going to be 6H2O.
3O2, thank you. 3 times 1. Okay, and then delta H reaction?
3 times 1 is 3O2, yeah. 4A3.
Yeah.
Times 4. 1450.5.
And that's minus. Right. So
Negative.
now, Ankira, did you have a question, or are you just helping me out?
No, I don't have no question.
Oh.
Thank you.
Yeah, thank you. All right. So now we should be able to cancel our 6 H2Os. Cancel. So we have 5 plus 3 oxygens. That's 8. We have 8 oxygens over here. So that you can cancel from 2 different places. So 8, as long as it totals to the same thing. And 5 carbon dioxides. And that will leave us with what's left, which is 5 carbon solids plus 6 H2s goes to C5H12. And when you add reactions, you add delta H values as well. So 3505.8 minus 1967.5 minus 1450.5. And I get 87.8 kilojoules per mole. So the question says, you canceled the O2 with not the same coefficients. I have 8 oxygens here, and between these 2 reactions, I have 5 oxygens and 3 oxygens. So this totals to 8. Yeah, good question. So yes, you're always canceling the same thing. But what's different about this is to get your 8, you have to look in 2 different reactions, but that's totally fine. And 2 other things I'll say about this. One is it will always work out. So I choose these problems so that they will always work out. And if it doesn't look like it's working out, I always start again because these problems, it's very easy to get lost in them. So if you find that you're not getting things to cancel out when you do it, so start with a fresh piece of paper. That's my hint for how I solve these if I make a mistake.
Okay. Excuse me, sir. I have one question.
Go ahead, Inkiro.
Turning to this particular question, because it is a kind of question that one can work over and over again. And if we are going to have this in exam, could you please extend the exam time, as in the time allotted for the exam, so that we'll be able to, even if we didn't get it, we can go over and over it again.
Okay, so good question. And then Awangofak, I'll tackle yours next. So, Nkiro, I have designed the exam with this in mind, meaning that I realize how these kinds of problems can take a long time. And I have designed it so that's why you have an extra at least 10 or 20 minutes. I think it was 80 minutes last time. But you should have plenty of time if you know how to do this basically. Like if you have the operating, like if you know what it means to flip a reaction and what it means to multiply a reaction, and then you will be fine. So, but you may not have all, like if you don't know and you have to go back to your notes and review this for 10 or 15 minutes, then just to figure out how to do it, then yes, you will struggle on that second exam. So, and what I will also say is for the exam, if you have a problem like this, it will more than likely only have 2 reactions to add, because every time you add a third reaction, it gets much more complicated. So
okay. I've done this severally on my own for the homework. I could not really be convinced with the answer that I got. So I don't know how it's gonna be. The problem is knowing the one to flip and the one to multiply. That is my problem. So I don't just know.
Well, I'll tell you what. So we have worked 2 of these, and what I will do is I do still have to go over more of the homework, but when we have time later in the class, we can do more of these. Like I understand that this is a complicated problem to solve, and so what we will do is we'll take as much time as we want. We have all day today, and so I will do. This will be the last one I do now, but we will have time maybe later in the this lecture time this morning, or we will have time later in the lab. Like it is my goal that by the time you get to the exam, you will feel comfortable with all these things. So now, so can I do the first reaction again? Let me tackle that.
I have a question, Professor. Okay.
So Mohammed, let me see. So I have one from Awangofak and one from Mary in the chat, but then Mohammed, you're after that, okay?
Okay, thank you.
So for the first reaction, what I did was I have, all right, so this is the reaction I'm trying to build. So meaning that I'm going to add up all these reactions to this one. And I see that C5H12 liquid is a product here. And I see that C5H12 liquid is a reactant in this first reaction. So, and I don't see C5H12 in any of these other ones. So that means that I have to take this first reaction and flip it. And when I flip it, that means I take my reactants and write them as products. And I take my products and I write them as reactants. And when I do that, whenever you flip a reaction, I take and change the sign of the delta H. So that's why there's a minus sign there. So, we'll talk more about this in future problems, but there is, and there is in the lecture outlines, what it means when you flip a reactant. Like, you basically turn a negative delta H, which is exothermic, into a positive delta H, which is an endothermic reaction, because it's like you're flipping, well, you're literally saying do the reverse of the process, because if here you're going from these two to the carbon dioxide and the H2O, if you do the reverse process, you can expect to take a reverse amount of energy, and a reverse amount of energy is the change of the sign of the energy. Anyway, so hopefully that's a little bit more along the talk about that. Mary, why did you...
Let me just ask this question. How do we get the 3,505.8?
So this number has to be given to you.
Okay.
Yeah. Why did you multiply the third by 3 again? Which chemical were you trying to cancel out? Good question. So this third one had 2 things that we needed to do. We needed to get 6 hydrogens on the reactant side, and we only had 2 hydrogens here, so that told us that we had to multiply times 3. And then we had 6 H2Os from a previous reaction, so we needed 6 H2Os to cancel out. So we needed to put something in the reaction, and we needed to cancel something out of the reaction. So that's why, and both of those had 2 coefficients here and 6 coefficients when we, so that's why we multiplied times 3. Cool. Now, Mohammed, you had a question?
For the explain my question, but I just want to know, because the one you flip, we have, which is CO2, and the first one, the reaction you give to us, which is the 5CS.
Yep.
So I want to know, how do you, because I thought like the 5CS is the main reaction, and how do you know that you can flip the CO2? Because I don't understand. You use you flip the CO2.
Okay.
And we have 5CS.
Okay. So so what's interesting about the CO2, the carbon dioxide, is it does not appear in the reaction that we're trying to build.
Yeah.
So, but we can see that CO2 is in 2 different reactions. So that means that we're going to have one reaction that has CO2 on one side, and the other reaction, and we don't know which one will, we don't have any idea necessarily which one it is, but we know that CO2 has to be on the product side for one of them, and on the reactant side for the other. So one of these reactions we know has to be flipped.
Okay.
So, yeah, no, these are puzzle problems, and so it's like if you did this and you said, I see 5 carbon solid, and you went immediately to the second reaction and wrote it out, and you noted that you had to multiply it times 5, like you could have done this first reaction first.
Okay.
Right? There's no set order that we have to do these in.
Oh, okay.
Yeah. So now my approach typically is, so I don't know if you remember how I balance chemical reactions, but I always look for the most complicated thing first.
Okay.
Because the most complicated thing almost never has to be canceled out. So, but if you just went straight through and you said, I need 5 carbons, so multiply this times 5, and that was your first reaction, and then you said, I need 6 of these, so let's multiply this times 3, and then you came back and did this one last, which totally still works.
Okay. Okay.
Cool.
All right. Thank you.
Sure. Any other questions? Okay. No, this is great. So we are going to get this, and we are going to be ready